A current source is connected across a PN junction diode as shown in the below figure. What is the voltage across this PN junction diode? We have to use diode current equation in order to know the voltage across this PN junction diode. One important point to remember is to observe the direction of the current source. Here the current source arrow is towards the P side. It means that the current is flowing like this into the P side of the diode and coming out from the diode through the N side, and again it is going into the current source in this direction. The whole direction is exactly opposite to this direction, that is the holes will be moving in this direction. As the current is entering the P side of the diode and leaving the N side of the diode, if the current is sufficiently large to forward bias the diode, then depending on the value of this current source I, this diode can act as forward biased. Nevertheless, if the direction of the current was in opposite direction, then the current would be entering the PN diode from the N side and leaving the P side. It means that clearly the diode is in reverse biased condition and the value of the current source I is nothing but the reverse saturation current IS. In our question, the current direction is entering the PN diode from the P side and leaving from the N side. So the diode would be forward biased. The diode current equation is ID is equal to IS into e power Vd by Vt minus 1. ID is the current through the diode. IS is the reverse saturation current. Vd is the potential or the voltage across the PN junction diode with positive referenced at P side and negative terminal of the potential referenced at N side. Vt is the volt temperature equivalent, which is kT by Q, which is 26 millivolts at room temperature. In forward bias condition, the drop across the diode, namely Vd, with positive reference at P side, is very high. In other words, the factor e power Vd by Vt would be very large when compared to 1, because Vd would generally be greater than 0.7 volts for a silicon diode to be forward biased, and Vt is only just 26 millivolts. So Vd by Vt itself is large and E value is 2.74. 2.74 power large value is even large, so 1 can be neglected. Taking logarithm on both sides, we get Vd is equal to Vt into ln of Id by Is. So this is the voltage across the diode with positive reference at P side.